Hello, welcome to paper discussion. This is the first paper of a series of paper for 2021 students. I gave you the paper about 3 days ago. You tried it. Now you are waiting for the discussion to understand your mistakes. To understand mistakes you have done in the paper. Then those who have not the paper right now, I have uploaded that one to my Telegram group also. The link is given below in the description. So you can go to that link and the Telegram group and collect your paper, try it. Thereafter, come to the paper discussion. It's very important to first try the paper before the discussion. So without trying the paper, if you come to just the discussion, you don't get 100% idea about this one. You don't get really the advantage from this paper discussion. And not only that, I told you, when you do the paper, you should follow the instructions strictly. Normal instructions, all of you know about that one. That means use of calculator is not allowed. You can't go through the previous note while you are answering the questions. And the time I have given for this paper, 2 hours. You have 25 MCQs, then 1 hour for that one. You have 2 structured essay, 30 minutes for that one essay question, 30 minutes for that one. So total is then 2 hours for the paper. So then again, you can't get more than 2 hours, right? So just after 2 hours, you should then stop the answering paper. So likewise then, you should follow some instruction. You should follow all these instructions strictly to answer this paper. Okay, then we are now ready to start the paper discussion. Before I go to paper discussion, I should explain how the marks are given for this paper. So as I told you, there are 25 MCQs, 4 marks per MCQ, then total will be 100. 2 structured essay, 30 marks per question, then total will be 60. 1 essay question, 40 marks per essay question, so total will be here again 40. Finally, for whole paper, there is a mark here 200 marks. Then you can get the marks out of 200. Thereafter, you can divide that by 2 and get your percentage. Then you can get your marks out of 100. So that's the way we have the marks for this one. Okay, let's jump to the paper discussion. Right. First question you are given is about electron configuration. As you can see, electron configuration is given. The above electron configuration represents. That's the question. But first of all, we can go for the total number of electrons given in the configuration. So you can see 1s2, 2 electrons, 2s2, 2 electrons, 2p5, 5 electrons, 3s1, 1 electron. When you add all of these electron, it should be 2, 2, it's 4, 4, 5, it's 9, 9 plus 1, 10 electrons. So which one can have 10 electron? It's given, fluorine, neon, O2 minus cyan. Those are the species given in the answers. But when you consider 10 electron, where do you find it? You find that one in the neon. You find it in neon. So when we write the electron configuration of neon, this is how we can write it. Neon, you get 10 electron. It's 1s2, 2s2, 2p. So far 4 electrons, then 6 more, 2p, 6. This is the ground state neon. If you write the electron configuration of ground state of neon, this is how we end up with. But is that the configuration given? No, what you are given is this one. It's given 1s2, 2s2, but this is not completely filled. It's 2p5 and 3s1. So in this case also we can get 3s0 here. So to get this configuration, what has happened here, one of this p electron jump to 3s. 2p electron jump to 3s. We know 2p electron has low energy, 3s have then high energy. then electron jump from lower energy level to high energy level. So that is called what? Excitation. That's called excitation. So because of that, this actually represent the excitation state of neon, not the ground state, right? So this is ground state. This should be excited state. So your correct answer for that one should be then excited state of neon. That's third answer. Second MCQ is about identification test, hydrogen sulfide and sulfur dioxide. Question is cannot be distinguished by. Okay, we go to this reagent one by one. Then we see the differences. Next, then when you consider hydrogen sulfide, sulfur dioxide, for the first reagent, what is the first reagent given? It's litmus paper. Can we distinguish these two? This is acidic. H2S is acidic. Sulfur dioxide is also acidic. Then once you use litmus paper, we can expect then same observation. But there is a special property in sulfur dioxide. Sulfur dioxide can act as a bleaching agent, or it can have bleaching property also. Bleaching property also. Because of that, sulfur dioxide can bleach the litmus paper. Then there is different observation, then we can use litmus paper to distinguish these two gases without any difficulty. Let's move to second one. It's lime water. Second reagent, lime water. Lime water, it's calcium hydroxide. When you pass H2S through calcium hydroxide, but we get calcium sulfide. But calcium sulfide is colorless solution. There is no any precipitate. There is no evolution of gases. There is no any color change. Because of that, you don't see any observation in that case. But once you pass sulfur dioxide through calcium hydroxide, what we get is calcium sulfide. Calcium sulfide, it's a white color precipitate. Calcium sulfide. This can be a white color precipitate. So is there any then differences here? Yes, of course. Then we can use lime water to distinguish these two. Next one, lead acetate paper. We can hold a filter paper dipped in lead acetate. Then question is whether we have two different observation. Hydrogen sulfide, lead acetate. What do we get? We get black spot, black color spot here. The reason for that one is the formation of lead sulfide, PBS. Lead acetate plus H2S, it can give a lead sulfide. Lead sulfide is a black color precipitate. So black spot. But do we get that type of situation in sulfur dioxide? Black? No. Sulfur dioxide plus lead acetate, it can give lead sulfide. It's then white. The filter paper is also white. So then there is no actually clear observation here. Then two different observation given. So we can use lead acetate to distinguish these two gases. Next one, HCl. And then fifth answer, none of the above. So once you then treat hydrogen sulfide with HCl, there is no any reaction. No any observation. And you can treat sulfur dioxide with HCl, again, no reaction, no clear observation here. Now you can see there is no any difference in these two cases when you use HCl. So then, can we then distinguish these two gases by using HCl? No, we can't distinguish. So because of that, your answer should be then fourth one. For the second question, correct answer fourth one. Right, so in this discussion then I don't give any extra notes. So if you want some extra notes regarding these concepts, better to stop the video and then write a note in your word. Thereafter you can continue the video. Clear? Let's move to a third question. Which one of the following which one of the following has the regular tetrahedral structure? To have tetrahedral structure, there should be 4 repulsive units around the central atom, 4 repulsive units. First one given XeF4, but when you write the configuration here, first answer XeF4, in XeF4, when you arrange the repulsive forces around xenon, you know, there are 4 bonds. But xenon group 18, there should be 8 valence electron. Out of 8, 4 involved in chemical bonding. Then there should be 4 more. 4 more means there should be 2 lone pairs here. Then total VSEPR here 1, 2, 3, 4, 5, 6. If it is 6, the geometry is, you know, octahedral and the shape should be square planar. Not the answer. Second one given, nickel tetracyanidonicolate ion. It's a NiCN4 2 minus. You know this one, if the coordination number of the complex is 4, there are 2 possible shapes. What are the 2 possible shapes we can have for 4 coordination number? One is tetrahedral, the other one is a square planar. But in the case of this complex ion, you know the shape, it's a square planar. It's not tetrahedral. Most of complex ions having coordination number 4 tetrahedral, it's okay. But some ions like tetracyanidonicolate and some ions like tetraamine copper 2, this type of ion should be then square planar. Because of that, this is not the answer. It's not then tetrahedral. Third answer given, BF4 minus. First of all, we should understand how BF4 minus ion is formed. You know the stable one is BF3. Boron has then electron deficiency here because there are only 6 electrons in boron valence shell. Since it is electron deficient, it's then looking for another electron pair. So it accepts electron pair from F minus. So this is how the dative covalent bond is formed. But the way we represent this one, you know, it's this way. We just put line here plus because it donate, but already minus, then plus minus cancel out. Then boron should be minus here. So that's how we get the structure. Then, you know, do we have any other repulsive forces around boron? No, in this BF4 minus, we get only 4 VSCPR. And all of these 4 repulsive forces are bonding electron pairs. Then you know the shape. What is it? Tetrahedral. So this is the answer. Let's go to the other things given. SF4. In the case of SF4, this is how we get the bonding arrangement. But you know sulfur from group 16. There should be 6 total electrons. How many electrons are available in the chemical bonding? Only 4. Out of 6, 4 given. So 1 remains. There are 5 VSAPR. The geometry should be trigonal bipyramid, but the shape should be seesaw, not the tetrahedral one. PCl4 minus. When you consider PCl4 minus, we have 4 PCl bonds like this. You know, phosphorus from group number 5. There should be 5 valence electrons. Out of 5, 4 involved in bonding. There is 1 electron here remaining. But this is PCl4 minus. You know the meaning of minus. Minus means what? Another electron is gained. Then where do you find that electron? It should be here. It is paired. This is how we get the structure for PCl4 minus. Now you see these 2 species are same. 4 bonding pairs, 1 lone pair. So the shape should be then, it should be seesaw. So the answer for this question should be third answer. We are in fourth question. What you are given free energy of formation of aluminium oxide and sodium oxide given. But the question is this. Select the correct statement. Sodium is able to reduce aluminium oxide to aluminium. Aluminium and sodium oxide do not react. Aluminium can reduce sodium. So it's about the reaction. I just consider some reaction here. Like this. Let's consider this. Sodium reacts with aluminium oxide, and I expect the product here aluminium and sodium oxide. I just balance this equation: 2 aluminium, 3 oxygen. This should be 3, 6 sodium and 2 aluminium. This is balanced chemical equation. We don't know whether this reaction takes place. We don't know whether this reaction is favorable, but we assume it and then try to calculate free energy change of this reaction. Delta G theta R, free energy change of this reaction. Because we know from the free energy change of the reaction, we can have some idea about the feasibility of this reaction. In theory classes you have learned it, if it is less than 0, that means negative value, the reaction, forward reaction is then a favorable one. If it is greater than 0, forward is not favorable, then in other words we can say backward is favorable. Let's try to calculate the free energy change of the reaction. There is equation for this. I think all of you remember that one. It's summation of free energy change of formation of products minus summation of free energy change of formation of reactants. But in this case, you know, we just multiply this by the stoichiometric coefficient. I put it here like m and here n. These are stoichiometric coefficients. Then if I write the equation for this particular reaction, products are aluminium and sodium oxide. First of all, we get 2 times free energy change of formation of aluminium plus 3 times free energy change of formation of sodium oxide, right? That's about the product minus then reactant. What are the reactants? We have 6 times free energy change of formation of sodium plus just free energy change of formation of Al2O3. That's how we have the equation. So I cancel these elements. Why? Because we know free energy change of formation for an element should be then 0. So you can just remove that part. Then we have come to the other part. 3 times it's a free energy change of formation of sodium oxide. It's given minus 377. Okay, that's minus. We have just formation of aluminium. It's minus 1582. You are given the unit for this one in kilojoules per mole. That's how we get it. But then we can find it out. You know, it is 3, 7, it's 21, it's 23, it's 11, minus becomes plus 1582 kilojoules per mole. Right? Then we get, this is large value, then 1, 8, 3, it's 5, 5, 1, it's 4, 1, 1, 0. So it's plus 451 kilojoules per mole. That's how we get the value. But now we can see it's positive value. Positive value. For the forward reaction, delta G theta R, that means free energy change of reaction is a positive value. If this one is positive, greater than 0, you know, forward reaction is not favorable. So which one is favorable then? Reverse reaction is favorable here. Reverse reaction is favorable. What's the meaning of that? Sodium cannot react with aluminium oxide, but aluminium can react with sodium oxide. Aluminium can react with sodium oxide and produce aluminium oxide and sodium. So reverse reaction here then favorable. Sodium is able to reduce, aluminium is able to reduce sodium plus 1 to 0. That's the meaning of this. So where do you find that answer? That's in third answer. You see, aluminium can reduce sodium oxide to sodium. It's the favorable reaction. Question number 5. Ratio of masses of 2 gas samples given. One is unknown, the other gas is hydrogen. But important thing, the conditions are same here. Hydrogen, let's say this is certain gas X. Volume of this given 1.2 liter. This is the hydrogen gas. Here the volume is also 1.2 liter. These are at same temperature and pressure. I just keep it like this, same temperature and same pressure. But what is difference here? The mass ratio of these 2 gases given. I assume here the mass is M1, here the mass is M2. So what you are given, mass ratio M1 over M2 given as 40. This is the information given. Now your question is to find out this. We compare that gas with these known gases, lighter than ammonia, lighter than chlorine, heavier than sulfur dioxide. So how do we compare 2 gases like this? What is the factor we need for that one? As example, if you consider hydrogen gas and sulfur dioxide gas, which one is heavy? Yes, hydrogen is a light gas, then sulfur dioxide heavy. Why? Its relative molecular mass. or in other words, molar mass. Hydrogen has 2, sulfur dioxide has 32 into 32, it's 64. So the one having higher relative molecular mass should be the heavy gas. Right, then what we need here, we need the relative molecular mass of unknown gas, molar mass of unknown gas. That's what we need. Let's see how to do that one. Since it is about volume and mass mean, here we can convert them into number of moles. Number of moles, volume, two gases at same temperature, pressure. I can apply then Avogadro's law. You know the condition for Avogadro's law? It should be a gas. Both of these two are gases, and these gases should be at same temperature and pressure. Those are in same temperature and pressure. So we can apply Avogadro's law. What is Avogadro's law? According to Avogadro's law, at constant temperature and pressure, volume is directly proportional to number of moles. But as you can see here, volume of two gas samples are equal, 1.2 liter, 1.2 liter. If the volumes are equal, what can you say about then number of moles? Since volume directly proportional to number of moles, volumes are equal, the number of moles of unknown gas should equal to the number of moles of hydrogen gas. That's the point here. But number of moles of unknown gas can be mass of unknown gas divided by molar mass of unknown gas. Number of moles of hydrogen will be mass of hydrogen divided by molar mass of hydrogen. Mass of unknown gas, I got it like M1. Molar mass of unknown gas, we don't know. That's what we have to find out. But the mass of hydrogen gas, M2. Molar mass of hydrogen gas, 2 grams per mole. By simplifying this, you can subject mx. Mx will be now M1 divided by M2 multiplied by 2 grams per mole. Do we know this ratio? M1 over M2? Yes, we know M1 over M2 is equal to 40. So then we multiply this ratio 40 by 2. So what we get finally, Mx is 80 grams per mole. Molar mass of this unknown gas is 80 grams per mole. Then easy to compare this. It is lighter than ammonia. No, ammonia 17. This is heavy. Heavier than N2O5? No, N2O5 that has really great that has a molar mass greater than 80. Gas lighter than chlorine? No, chlorine it's 71, less than this one. Gas heavier than sulfur dioxide? Of course, sulfur dioxide it's 64, but this is 80, then unknown gas is heavier than sulfur dioxide. So answer is fourth one. Question number 6. A salt made by bivalent ions X and Y. What's the meaning of bivalent? Bivalent mean bi mean here 2, valency 2. Charge should be 2, plus 2, minus 2. 2 ions, that means cation and anion. Cation plus 2, anion minus 2. That's the meaning of this. Which is capable of decolorizing acidified KMnO4. The salt is likely to be. First in anion, cation should be plus 2 type, anion should be minus 2 type. That's bivalent 2 ions. Then ferric oxalate can easily be removed. Why? Ferric mean Fe3 plus. It's given bivalent. Bivalent mean 2 ions with valency 2. Then ferric means, X suffix for high oxidation number. Ferric mean Fe3 plus. Can ignore. Magnesium sulfide plus 2 minus 2, okay. Ferrous sulfate, a suffix low oxidation state plus 2, then we can keep it. Stannic chloride, SN has plus 2 and plus 4. Stannic ic suffix for high oxidation number, that means it's plus 4, can be cancelled. Ferrous oxalate, so you can keep it again. Right, then the question is second one, third one, or fifth one. Each of which is capable of decolorizing acidified KMnO4. What happened when you decolorize acidified KMnO4? MnO4 minus in acidic medium, it goes to Mn2 plus. Mn2 plus and water. It's not balanced. So if I balance it, it's 4 and 8H plus. This is balance equation for this one. During that case, plus 7 goes to plus 2. Therefore, this is reduction. This is a reduction. Then KMnO4 undergo reduction and decolorize. MnO4 minus is purple. In acidic medium, Mn2 plus is colorless. This is purple and this is colorless. Purple goes to colorless during this reduction. Then each and every ion here can decolorize permanganate. What's the meaning of that? X2 plus should oxidize because then only permanganate undergo reduction. Y minus 2 should oxidize, then only permanganate undergo reduction. Then both the positive cation and negative anion should oxidize here. But once you consider magnesium sulfide, sulfide can be oxidized to sulfate, but magnesium no. Ferrous sulfate, ferrous can be oxidized to Fe3 plus ferric but not sulfate. Then fifth one, ferrous oxalate. Yes, ferrous mean Fe2 plus, it can be oxidized to Fe3 plus. During that case, this reduce and decolorize. Oxalate, C2O4 minus, that can be easily oxidized to carbon dioxide. So during that reduction, oxidation, permanganate will reduce and decolorize. Therefore, correct answer for this question, fifth one. Now we have come to seventh question. Two ideal gases X and Y are present in separate containers. The density of X is 3 times more than that of Y. Molar mass of Y is twice that of X. If both gases are at same temperature, the question is ratio of the pressures. This is one vessel, it has X gas. This is another vessel, it has Y gas. Density of X is 3 times more than density of Y. Then density of Y D, then this should be 3D, 3 times. Molar mass of Y twice that of X. Molar mass of X M, then Y 2M. Both gases are at same temperature. Temperature of these two are same. But the question is pressure. Here pressure Px, here pressure Py. You are asked to calculate the pressure ratio. How do we get it? In this particular cases, we don't have time to derive equations and then use it. This is MCQ. Therefore, like PV equals nRT, it is better to remember some derived equation. Do you remember the equation which gives relationship between pressure and density? Yes, it is P equals dRT over capital M. For ideal gases, this is the relationship between pressure and density. So now you can then substitute. So now you can then apply this equation to two gases. If you apply this to X gas, you get pressure Px and density 3D RT over M. That's how we get the first equation. Second gas Y, when you apply that to Y, what we get Py equals it's dRT divided by 2M. This is second equation. What we need is ratio between these two, then we divide first one by second one. So you get Px over Py equals what? Yes, it should be something like 3dRT divided by M. This is 2M divided by dRT. So what we get finally? M cancel, dRT cancel, 3 into 2, it's 6. 6 means 6 over 1. Ratio should be 6:1. So according to that, the answer is fourth one. Question number 8, that is from chemical calculation. We have iron plate with 50 gram. We dip that, immerse that one in 250 cubic centimeter of copper sulfate. After some time, the mass of the plate was 52 gram. Mass of copper deposited is the question. This is your iron plate. The mass of this one is 50 gram initially, 50 gram. But once you immerse this one in 250 copper sulfate solution, what will happen? This is what happened. Iron is more reactive than copper. So if you add the iron to copper sulfate, this copper will be displaced by iron, right? So how can this happen? If we will react with copper 2 plus like this, if we will oxidize but copper will reduce. Now this is balance equation. It's balanced in terms of atoms and the charge wise also. The physical state Fe here should be solid. Copper 2 plus, it's aqueous form. This is solid. This is again aqueous form. So then what happened to iron? Solid goes to aqueous. That means certain amount of iron now dissolves. Let's say it's something like that. This part then dissolves. But at the same time, copper solid deposited. Let's say copper solid deposited like this. This is copper. So we have then remaining iron plus copper deposited. Then addition of these two, mass given 52 gram. That's the information given. Now your question is to find out the mass of copper deposited. I take it like simply. That is your question, mass of copper deposited. Let's see how to do that one. So can we take it like something like that? Final mass 52, initial mass 50, then 52 minus 50, 2 gram. You are given that 2 gram as an answer, fifth one. So can't it be like that? No, it's not simple like that. You know why? Because this is not Fe completely. It is Fe plus copper. Then you can't just subtract mass of Fe from mass of Fe and copper to get the mass of copper deposited, because relative molecular mass of these two elements are different here. So then how do we get it? Right, this is how we can simplify this. I get the initial mass of Fe 50 gram. This is initial mass, right? Not moles, mass. Then I take remaining mass or mass deposited. Here in the case of copper, I got M deposited. Simple M deposited. Then what will be the reacting mass? In the case of reacting mass, it should be simple M. You know, initially the mass of copper is 0, but M deposited finally. That means reacting mass should be M. But you know, we can't use a stoichiometry by considering masses. Then I convert this into mole. Then reacting moles. The reacting moles of copper will be M divided by 64. Moles equals mass over mole mass. Since 1 mole of copper deposited from 1 mole of Fe, the reacting moles of Fe should be again M over 64. That should be M over 64. That's reacting moles. Then what about the reacting mass of Fe? It will be the mole into molar mass. It's M over 64 multiplied by molar mass of Fe. It's 56. Actually, reacting mass of Fe mean the mass of Fe dissolved. So initial mass is 50 gram. This is mass of Fe dissolved. What about then remaining mass of iron? That will be initial minus mass dissolved, 56m divided by 64. Clear? So actually in this case, if I substitute the values, units, grams per mole, it's cancelled out. So we end up with something like this. So now you can see the final mass 52 will be the mass of Fe remaining. So what is it? It's 50 gram minus 56m divided by 64 plus mass of copper deposited. So what is it? I got it like simple M. So that should be 52 gram. That's given finally 52. Now we can simplify this and finally get simple M. When you simplify this, you will end up with 16 gram. So what is the answer for this? It's 16 gram. Second answer. We have come to now 9th question. A compound X is white, amphoteric solid. It becomes yellow on heating, but again becomes white on cooling. When you learn inorganic chemistry, you talk about this one, definitely. Maybe you remember that one. This is a special feature of zinc oxide. When you heat it, it's yellow, but when you cool it down, it becomes white again. And you know zinc oxide again, amphoteric oxide. So it should be zinc oxide. Answer is none of this. 10th question, which one of the following compound has the highest CH bond energy? Highest CH bond energy. So how do we get it normally? 10th one. Normally bond energy can be compared like this. First thing is this, whether the bond is single, double or triple. Normally, if you get this type of multiple bond between two atoms of same element, when the multiplicity increases, we know bond energy increases. That's the point. But in this case, all CH bonds are single bonds because valency of hydrogen is 1. It's not then factor. Second thing, we can consider, second factor, there can be atomic radius, right? So if you get then large atomic radius, we know bond length increases, then bond energy decreases. But since we get carbon hydrogen always, then atomic radius it can be same. So then what is the difference here? The difference here is actually the hybridization. In this particular case, it's the hybridization of carbon actually. Normally that carbon can have this type of hybridization, Sp, Sp2 and Sp3. When p character increases, size of hybrid orbital increases. When the size of hybrid orbital increases, bond length increases. When bond length increases, bond energy decreases. Did you get this idea? So Sp something like this, Sp let's say this much, Sp2 will be this much, Sp3 will be something like this. P character increases, size increases. Then during formation of CH bond, Sp hybrid orbital of carbon linearly overlap with S orbital of hydrogen. That's how we get it. So when you consider that overlapping, you can see P character increases, bond length increases. Bond length increases, bond energy decreases. So which one has the lowest bond energy? It should be in the case of Sp3. But the question is about highest CH bond energy. Then it should be in SPS case. So where do you find SPS overlapping? In CH bond. First one C2H6. C2H6 bonding arrangement, if I consider it, it's something like this. This is how we get it. Sp3S overlapping, not the answer. Second again C2H4Br2, it's something like this. We consider CH bond. C2H4Br2, again Sp3S. Next C2H4. C2H4 we get it something like this. Sp2S. Next fourth one C2H2. C2H2 is something like this. SPS overlapping. All they have same bond energy, no? So now you see SPS is found in this case. So the correct answer for this should be fourth one. 11th question, you are given 4 molecules. You are asked to get the highest dipole moment. We know simply dipole moment depend on the polarity. When the polarity of the molecule increases, dipole moment also increases. That means dipole moment, polarity, those are directly proportional. Then I try to compare first here polarity, then I can compare the dipole moment easily. This transform. When you consider transform, it's normally non-polar. You can see chlorine is more electronegative than carbon, but the forces are opposite, then we can assume it's cancelled out. CH3 electron releasing group like this, again opposite, same force, then cancelled out. So this can be taken like a molecule with a very small polarity. This is again transform according to that, trans. If it is trans, again the forces are cancelled out, the polarity will be very small. But when you consider this carbon, it's Sp2 hybridization. There are 3 repulsive forces. Sp2 means it's trigonal planar. When you consider this arrangement, carbon is more electronegative than hydrogen. 2 bonds polar like this towards carbon. And next carbon and oxygen, you see oxygen is more electronegative than carbon. Then all the forces now to same direction. Because of that, in this molecule, there can be large electronegativity difference like this. There can be large charge separation like this, delta plus, delta minus. So compared to these two, this has high polarity, this has then high dipole moment. But what about this? In this particular case, CH3 releasing electron towards carbon like this. But CH, again, carbon is more electronegative than hydrogen. So this is how bond polarity. We have bond polarity. Again, opposite forces, but not same. There will be some net force here. But in that case, since these are in opposite direction, the forces will be cancelled out up to certain extent. Therefore, compared to this, we can see this one is also the polarity is small compared to this one. So where do you find the large polarity? It's in methanol molecule. So that is where you get the highest dipole moment. So answer for that should be third one. Question number 12, that's from again chemical calculation. What you are given oxide, and it reacts, it reduced by hydrogen, then it goes to metal and water. So we can first write the balance equation for this. 12th question, yes, Z2O3 plus hydrogen gives the free metal Z and water H2O. Is it balanced? It's not balanced, we have to balance it. Since 3 oxygen, we just multiply this by 3, 6 hydrogen, it should be 3 here, 2 Z, yes, that's balanced chemical equation. Here we get 1. Then you are given the mass of oxide given 0.1596 gram. Other than that, you are given the mass of hydrogen 6 milligram, but we convert milli to gram here. We don't keep milligram, we take gram, because when you convert that into number of moles, molar mass is kept in grams per mole. That's why the mass should be in gram. Then the question is this, the atomic weight of the metal, that's a question. How do we get it? Simply the reactant molar ratio between these two is 1:3. We just write it. Yeah, I write it something like this. Reactant mole of oxide over reactant mole of hydrogen is given by the stoichiometry. But reactant mole of oxide can be given like this. Mole is mass over molar mass. This divided by the molar mass. Molar mass of this, the question is to find out the atomic weight of Z. So I keep it like A. Okay, then 2Z, then 2A plus 16 into 3, it's 48. That's divided by the moles of hydrogen. Its mass 6 × 10⁻³ divided by the molar mass 2 grams per mole. I just ignore that unit. That's equal then 1/3. Then only unknown parameter here is A. You can find it out. So let's take gram cancelled out here. Then 2/6 mean again 3. Then these 3 cancel with this one. Okay, so what do we get now? We get something like this, 0.1596 divided by 2A plus 48 is equal to 110⁻⁻3. That means 2A plus 48 equals 159.6. Then 2A equals 0.6, it's 1 and 1. This is, then what about then A? A will be half of that. It's 5, then 10, 11 mean again 5, then 16, then 8. 55.8. Fourth answer. Question number 13. But in the question number 13, there is a problem in the data. So it's I should give then all for that one. Here 10 milliliter 0.1 m HCl, 10 milliliter 0.1 m KOH. The rise in the temperature was observed to be 4. If 100 milliliter of 0.1 m HCl and 100 milliliter of, it's given just 0.01. It's by mistake, it should be 0.1 m. It should be 0.1 m. KOH is mixed in the same vessel. The rise in the temperature would be. So here it's the reaction between KOH and HCl. It's about base and acid. Acid-base neutralization. You know, acid-base neutralization is an exothermic reaction. Exothermic reaction. You know, during that exothermic reaction, what happened? 1 mole of H plus aqueous combined with 1 mole of OH minus aqueous to produce 1 mole of water. For that, we have a certain value. It's minus 57.1 kilojoules per mole. You remember that one. So then I start with that point. You know, H plus aqueous, OH minus aqueous, H2O liquid. This is the reaction we can have in acid-base neutralization. If all the other factors remain constant, you know, this has a certain value for the enthalpy change, I take it like Q. Q energy released here, Q kilojoules per mole, right? Kilojoules per mole. Per mole mean it refers number of moles of liquid water formed during the neutralization. If 1 mole of water form, then Q energy released. That's the meaning of that. I don't put minus here, I use the word release. Here the question is rise in temperature would be. So when when certain energy released, now temperature will increase. Okay, now look at this one. In the case of first data, HCl react with KOH giving KCl and water, right? The moles of HCl given 0.1 10. So 0.1 10 10 to the power of minus 3. N equals CV. KOH moles given 0.1 10. Again N equals CV. We get same number of moles here. That means 1:1 molar ratio is also there. Then you can get the moles of water formed here 0.1 10 10 to the power of minus 3. That's the mole of water formed during this neutralization. But since 1 mole has this much energy, for this number of moles you can say the energy release should be 0.1 10 10 to the power of minus 3 multiplied by Q. During this neutralization, this much energy is released. But when you apply Q equals mc theta, Q equals mc theta, here Q is this energy release. But what about the mass of this sample? What about the mass of this sample? It should be density into volume. Mass is not given, but you can just take density like D, then volume is 10 and 10, it will be 20 milliliter. Density into volume. MC, the specific capacity, we take it like C. We have same vessel, same solution. Therefore, it remains constant. And what about the theta? Temperature change. It's given for degree Celsius. Since it is difference, you can keep it like Celsius or Kelvin. It doesn't matter. Let's say for Kelvin. The answers are given in Celsius. Then we can keep it Celsius. It's okay. So this is how we get the first equation. I label this one as first equation, right? Then we go to the second situation. In second situation, you know, the number of moles of HCl is different. It's 100.1. 0.1, 100, 10 to the power of minus 3. KOH is also, I ask you to change this to 0.1. 0.1, 100, 10 to the power of minus 3. Then same number of moles are there. Both of these two consume. According to that, mole of water in the case of second case should be 0.1, 100, 10 to the power of minus 3. That's the mole of water produced in second situation. Since 1 mole gives this much energy Q, this should be, this amount should give 0.1, 100, 10 to the power of minus 3 times Q. That's the Q energy. That's the heat. Then mc theta. Here mass is again density into volume. Since same substance available in the second system also, we can assume density is same, but the volume different. It's 200 milliliter. That's multiplied by same specific capacity is there because same solution, same vessel, and we don't know temperature difference here. That's the question. We keep it like theta. Then this is labeled like 2. Now what we need to calculate theta, only thing you can do, just divide second one by the first one. When you divide second one by the first one, you end up with the theta. As you can see here, 0.1 cancelled out, 10 to the power of minus 3 Q cancel, 100 over 10 mean 10. This side C cancelled out, D cancelled out, 200 over 20 again 10. Then that 10 to cancel with this one 10. So what is finally remaining? Temperature difference will be again 4 degree Celsius. 4 degree Celsius. So anyway, this data is given as just 0.01. If you substitute 0.01 and do the calculation, you don't get value. I mean, none of this value is the answer if you get 0.01 here, because if it is 0.01, you know that's the limiting region. If it is limiting region, the amount of water produced should be 0.01 100 10 to the power of minus 3. Then heat release should be 0.01 100 10 to the power of minus 3. According to that, if you do the calculation, you don't get answer. You get answer, but none of these answers. So anyway, then all for this question. We have come to the 14th question. Standard bond dissociation enthalpy of bromine given 193 kilojoules per mole. Calculate the wavelength of the electromagnetic radiation required for dissociation of a single bond of Br2. In this type of question, you may do this type of, there is a common mistake. Sometimes you do not pay special attention to this one. Dissociation of a single Br2 bond. Means how many Br-Br bonds you break here? It's only one Br-Br bonds break. Then the energy is given 193 kilojoules per mole. It's given per mole. Per mole means how many Br-Br bonds? There are Avogadro's number of Br-Br bonds. So that is the important thing we should consider here. In 14th question, it's given 193 kilojoules per mole. That means for 1 mole of Br-Br bond, the energy given 193 kilojoules. That's the meaning of this. But 1 mole of Br-Br bonds mean this number of Br-Br bonds. For that, it's 193 kilojoule. That's the meaning of this. But what we break here, only one single bond. Then you can find out first energy required to break a bond. Question is wavelength, but we know then relationship between energy and wavelength equals hc over lambda. Once we get energy for one bond, you can apply that equation and get the wavelength. So you know how to get it. E divided by 193 kilojoule is equal to 1 divided by this. Kilojoules per mole and per mole cancel out. We end up with kilojoule. So what is energy now? It's 193 divided by 6.022 10 to the power of 23 by its kilojoule. That's the energy we have. But now the question is not the energy but wavelength. We know the relationship between energy and wavelength. It equals hc over lambda. Then lambda will be hc divided by E. So hc is a constant, Planck constant. You know that one. It is 6.626 into 10 to the power of minus 34 joules second. C, you know, it's again constant, 3 10 to the power of 8 meter per second. And energy given is this 193 divided by 6.022 10 to the power of 23. But in this case, the unit is kilojoule. Here we substitute this Planck constant in joules second. Therefore, you can't keep kilojoule. Then kilo can be replaced by 10 to the power of plus 3. This is another mistake you can do about the units. We have to be very careful in the case of calculation. That's regarding actually unit. Now we can see then only here joule cancelled out, second per second cancelled out, and finally we end up with meter. Then meter, that's acceptable unit for lambda, wavelength. But the answers are given in, yes, all of them are given in meter. So when you simplify this, you end up with actually this answer 1.67 into 10 to the power of minus 7 meter. So it should be first answer. Okay, then if you have not done the paper and now just you are in the paper discussion without doing the paper, sometime you may feel that I continue this paper discussion quite fast. So that's the case. That's what I told you. So if you first try each and every question in the paper and come to the paper discussion, you don't see this discussion as a quite fast discussion, right? So you tried it, you have very good idea about the question, then you can understand what I am explaining here. You can identify your mistakes. Okay, and the other thing, you know, normally, and the other thing, you know, I don't discuss here any extra thing. I don't explain any theory parts here. What I am doing here, just to show you how to get the answer for the given question quickly, right? Short and simple method, because time is very important in the examination. Short methods should be used in these cases. And the other thing is, in this video I don't then take some extra time to discuss some other matters, because these days, you know, the most important thing for you is actually the data. If I then just discuss some extra things and then increase the length of this video, it's not good for you. It consumes then more data. So that's why I just try to finish this discussion within short time. I hope then this level is enough for you to understand your mistakes. Right, let's move to the question number 15 then. Freshly prepared chlorine water is added to aqueous solution of some halide salt containing some CS2. After shaking the content, a violet color appears in CS2 layer. The halide ion is. So once I consider halide ion, what are halide ion? Halide ion, it's X minus. This can be fluoride, chloride, bromide, iodide, right? Acetate, like that. These are halide ion. But we pass chlorine water. You know, the reactivity of halogen decreases on descending the group. That's what you learn in theory classes. Reactivity of halogen decreases on descending the group. Then fluorine is more reactive than chlorine. That means chlorine is not able to displace fluorine. So therefore it can't be fluoride here, because if fluoride is there, there is no reaction, there is no observation. But it can't be again chloride. Why? Chlorine plus chloride, we get Cl3 minus sign, but there is no any observation, there is no any color change. Therefore it can't be chloride. But chlorine is able to displace bromine and iodine. You know, if chlorine pass through then solution containing bromine, we get Br2 and Cl minus. It's not balanced. It can be balanced like this if you want. When you pass chlorine through a solution containing iodide, it gives I2 and Cl minus like this. So then there is a reaction and there is observation. But here we take a CS2 layer. You know, two solvents are there. Aqueous means water. Here aqueous means water. Water is a polar solvent. Other solvent is CS2. What about CS2? It's again solvent, but it is non-polar solvent. Then polar, non-polar, those are immiscible each other. This reaction takes place in aqueous medium. Okay, assume Br2 here. Br2 produce in aqueous medium. If Br2 produce aqueous medium, this can distribute to CS2 layer also. It's possible. What about Br2 color in CS2, non-polar medium? This is inorganic chemistry. In non-polar medium, Br2 is a brown. It appears as brown solution here, right? But if I2 is formed in aqueous solution according to this, I2 can distribute to CS2 layer also. If I2 is present in a non-polar solvent like CS2, this is where we get violet color. Then observation is given here, violet. Then halide ion should be iodide. Iodide should be this halide ion. Then only we can get this type of observation correctly. So answer should be first one. Right, we have come to question number 16. Next, question number 16. By what amount volume of a gas increases when its temperature is increased from 37 to 300 level? Actually, there are several ways to do this question. This is regarding volume and temperature. So we get volume temperature relationship. It's under Charles' law. We can assume constant pressure here. It's not given, but we have to assume it, right? constant pressure. Under constant pressure, volume is directly proportional to absolute temperature. That's the Charles law. V1 over V2 equals T1 over T2. By using that one, again we can find out by what amount volume of gas increases. But I'll explain here another way. Do you remember the graph we draw in Charles law? It's something like this: y-axis volume, x-axis temperature, but measured in degrees Celsius. This is 0, and when you extrapolate this meets x-axis somewhere here. So this is actually experimentally found. This is minus 273.15, but simply we can take it like 273 for convenience, right? Now I mark 37 Celsius. So what is 37 Celsius? 37 Celsius plus 273. 37 plus 273 is 310 Kelvin. Okay, let's say it's somewhere here. 37 Celsius or 310 Kelvin. At this temperature, volume of the sample, I take it like this value V1. Next temperature is given 311. This is 310 Kelvin. Then 311 Kelvin mean it's just 38 Celsius. Then at this temperature, I take the volume of the sample somewhere here, V2. Now what is your question? By what volume of gas increases when the temperature increases from here to here? When you get this one, this is where you can find it. So what is this? As you can see here, this one is delta V. That is the question actually. By what volume of gas is increased? Initially we had V1, but then it increases to V2, then increment is then delta V. That is your question. So, but when you consider this triangle, here you can see I take this one as theta, okay, then straight line, this should be again theta, right? Then what about this difference? That will be the volume at 0 Celsius or 273 Kelvin. I take it like V naught. What about this distance? That distance will be this. It's 273.15, but approximately we can say it's just 273. What about this difference? 37, 38, it's just 1. Now you can see, I write equation for tan theta. Here, according to that, it's V naught over 273. Here tan theta will be what? It's delta V over 1. But these two are equal. Okay, now you can say, therefore, delta V over 1 equals V naught divided by 273. So delta V is our question. Then it can be written like 1 over 273 into V naught. Now you can understand the answer here. It's 273rd part of V naught. V naught means volume at 0 Celsius or volume at 273 degrees Celsius. So second one is the possible answer for this. Question number 17 from unit 1. It's very easy. The first four ionization energies of element is it given. Without using the values, I just try to plot it like this. This is energy, let's say ionization energy, and this is removal of electron. We remove how many electrons? 1, 2, 3, 4. 1, 2, 3 and 4. The values, okay, let's take this is 1000, then this is 2000. If you keep same gap, 3000, 4000, 5000, 6000, 7000, like that. For the first electron, you should supply 734, it's somewhere here. For second electron, you have to supply 1400, it's somewhere here. Next, you should supply 7,700. So where is it? It's somewhere here. Fourth one, it should be 10,000, then 7, 8, 9. So it should be somewhere here. So when you then connect these points, we end up with this type of graph. Here there is a huge gap between second and third ionization. You know how to explain the reason for this large gap. How can we explain it? If you remember, in the valence shell there are how many electrons? 2 shells are there. That means outer shell you have 2 electrons. Then third electron is removed from the inner energy level. That's the meaning of this, because once you remove it I1, it's okay. Once you remove it I2, okay. This is larger than this because after you remove first electron, the nuclear attraction for remaining electron increases. But when you go from I2 to I3, there should be large gap. You know why? Because this electron is very close to nucleus compared to this. That means this electron strongly bound. The other thing is, once you remove 2 electron, nuclear attraction for the remaining electron further increases. Because of 2 reasons here, there should be large gap. Okay, then this element has 2 electrons in the valence shell. Then 2 electrons in the valence shell. So what is that group then? It should be group number 2. If it is group number 2, what could be the charge? Plus 2. So the answer is second one. Question number 18. Combustion of hydrogen in a fuel cell at 300 given. It's given 2H2 gas react with O2 gas to give 2H2O gas at 300. If delta H and delta G are these two, delta H for the reaction given minus 241.60, delta G given minus 228.40 kilojoules per mole. Actually here per mole refers 1 mole of water. But you have to understand this. In the equation there are 2 moles of water. The value of delta S for aforesaid process. That means we have to find out delta S for the given equation. Delta S for the given equation. So sometimes you don't notice that one. Some student can have this common mistake. You don't notice this one, 2 moles. You calculate it for 1 mole. Actually, these data are given for 1 mole. Then you know how to calculate it. It's delta H equals delta H minus T delta S. Everything available except delta S, you can find it out. But if I use delta G minus 228.40, what is it? It's kilojoules per mole. What is that? It's 1 mole of water. Delta H then should be minus 241.60 kilojoule, but that's for again 1 mole of water. Minus T, it's 300 Kelvin. You know, it should be substitute in Kelvin. For that you can find out delta S. When you simplify this, you will see it's minus 44 joule. Keep that in mind. It's kilojoule, but we convert that into joule finally. It's minus 44 joule. Is that the final answer? No. So far we consider only 1 mole of water. We calculated this one for 1 mole of water. But in the process there are 2 moles of water producing. Because of that, the final answer should be 2 times of this. You know, when you multiply this by 2, it should be minus 88 joule. So the correct answer is minus 88. It's second answer. I saw some of you have given fourth answer. It's minus 44. That's wrong. Question number 19. Some pale green crystals are strongly heated. The gases given off are passed into a container surrounded by ice. Temperature of the sample is very low. And then through a solution of acidified KMnO4. KMnO4 is decolorized. That means we take gases, then we reduce the temperature of that one and take that those gases through KMnO4, KMnO4 is decolorize. What's the meaning of that? It reduces to Mn2 plus. Then gas should oxidize. Since it goes to Mn2 plus, the solution is acidic. That means gas dissolved in water should give then acidic solution. That is another information we can get it. A waxy white solid is formed in the ice container. Low temperature, then it solidified. This is dissolved in water. The solution will. Okay. Here I directly go to the answer and then explain. In this particular case, green crystal should be ferrous sulfate. Once you strongly heat this one, it gives ferric oxide, sulfur dioxide, sulfur trioxide, two gases. This is not balanced equation. You can balance if you want, but here balancing is not necessary to answer this question. Two gases are given of sulfur dioxide, sulfur trioxide. Then we pass this through ice. Ice means it has water. If it has water, this is converted to sulfurous acid. This is converted to sulfuric acid. These are the two things we have when you pass this through water. Right, here ice, because the temperature we kept here is very low. Thereafter, when you pass this through potassium permanganate, you know what happened? Potassium permanganate. Since this has +7, this has +4, this has +6, there can be oxidation reduction reaction. Acidic solution, then this goes to Mn2 plus, then decolorize. At the same time, sulfurous oxidize. Sulfurous now oxidized to sulfuric. Here there is no change in sulfuric. So now finally what we have? Sulfuric. Then waxy solid. White solid should be then sulfuric solid. It's solid because temperature is very low. This is dissolved in water, then it becomes again sulfuric aqueous. Then that solution, first one gives a precipitate with silver nitrate. No, because silver sulfate is not a precipitate. Gives a precipitate with barium chloride. Yes, once you treat with barium chloride, you know what happened? Barium chloride gives barium sulfate. You know barium sulfate is a white color precipitate. So the correct answer for this should be second answer. Let's move to 20th question. This is again from gaseous state of matter. This paper covers only the first 6 units. Some of you have not completed organic chemistry and the other physical chemistry and industrial environment. Because of that, I prepared the question only from the first 6 units only. Right? So later we will then add the units one by one and cover the whole syllabus. Glass bulb containing 4 grams of argon. It's a glass bulb. If it is glass bulb, first thing we can assume volume remains constant. Glass bulb, volume constant. Temperature T, recorded pressure P. The bulb is now placed in hot bath having temperature 50 degree more than T. In order to maintain same pressure, 0.8 gram of argon has to be removed from the bulb. The value of T is okay. Normally in gaseous state of matter, the question from gaseous state of matter, you have 2 states. Here again you are given 2 states. These are the glass bulb. I told you volume is kept constant here, glass bulb. We can assume it. What's the gas available? Argon. No any other gas. Mass of the first sample given 4 gram. Then from here to here, 0.8 gram of argon has to be removed. Then once you remove 0.8, what is remaining here? It's 3.2. 4 minus 0.8, 3.2 gram. But we have to keep pressure constant. Then it's P in both sides. Temperature, initially T. Final one is T, but 50 degree more than T. Here you can assume T directly as Kelvin. It's okay. Why? This 50 is not Celsius. I mean, it's a change. Temperature change is same. I mean, when you consider express temperature change in Celsius or Kelvin, you get the same value. Because of that, I can assume these are given in Kelvin. Actually, no need to assume, it's given. T is given in Kelvin. Right. Then only thing you have to do is just apply PV equals nRT to both sample and equate them. You know, here according to this, it's PV equals N. N means 4 gram divided by the molar mass of argon R and temperature is T. This is first sample. This is to PV equals nRT to first sample. Then apply PV equals nRT to second sample also. Still pressure P, volume V equals N. Now 3.2 gram divided by molar mass. Same molar mass, same gas. And R, and what about T here? T will be T plus 50. I label this one as second equation. Then by first one and second one, you can say PV equals. Then you can say 3.2 gram divided by MR T plus 50 is equal to 4 gram divided by MRT. Then you can see these are easily cancelled, R cancelled out, M cancelled out, gram cancelled out, 4 cancelled out, it's 0.8 here. You can get 0.8 T plus, this is 0, 40, then it should be 40 equals T. So what about then T? When you take point T to this side, it's T minus 0.8, it's become 0.2 T, that's equal 40. Then T equals 400 divided by 2 means 200. Since T is in Kelvin, it should be Kelvin 200. Second answer. Okay, last 5 questions in the paper. This is different from the previous one. The previous case, you know, there are 5 answers. You have to select only one answer, the correct answer. But in this type of question, you know, in your paper also, you get this type of question from 30 to 40. 10 question will be given from this type. Then most of students find this type sometimes as difficult. Yeah, it is. We need more time for this. We have to go to each and every statement and then check whether the given statement true or false. But in the previous type, you know, once we find out the answer, we don't have to go to the other. But if you want to make sure that your answer is that, then you have to go to the remaining answers also. But here, we must go to each and every statement and see whether the given statement true or false. Right, correct responses regarding the shape of ions or molecule. pH3 is tetrahedral considering electron pair arrangement around the central atom. Is that true? Question number 16 from bonding. It's pH3. You know pH3, it's something like this. We have 5 electrons around phosphorus, 3 involved in bonding. You get one more pair. Then total VSC PR 1, 2, 3, 4. 4 repulsive forces mean the geometry should be tetrahedral. Geometry should be tetrahedral. That's true. Considering the bond arrangement around the central atoms, you are given XeOF2, COF2 molecule have the same shape. You can say these are different. I mean, you know, central atom xenon, central atom here, other one carbon. Those are from 2 different groups. Then they should have definitely different repulsive units. If I draw it and show you, then you can get it, but no need to draw it. We get XeOF2 like this, but xenon from 18, 8 electrons, there should be 2 pairs like this. But once you go to COF2, central atom COF2, carbon from 14, 4 electrons, but all 4 electrons involved in bonding, no more lone pairs. Here 1, 2, 3, 4, 5 repulsive forces, here 1, 2, 3. Can they have same geometry? No, that's false. HOBr is a linear molecule. When you look at this molecule, we can say yes, it is true, because we have oxygen central atom, 2 atoms around oxygen. But no, we can't get the answer easily. HOBr like this, you know, oxygen 16, group number 16. There are 6 valence electrons. Out of 6, 2 involved in bonding, but there are 2 lone pairs also. What about 2 bonding pair, 2 lone pair? Is this the shape linear? No, it is angular shape. C is also wrong. ICl2 minus is trigonal bipyramidal considering the electron pair arrangement around the central atom. ICl2 minus, how can we draw it? It's simply this one, ICl2 minus. I is the central atom. We put 2 chlorine like this. Then valency of chlorine, you know, it's a single bond. One valency, so single bond. Iodine, there are 7 electrons. If I assume it gives 1 electron for this, 1 electron for this, out of 7 there are 5 more electrons. We can place 5 more electrons like this, 2 pairs and 1 electron. This is simply ICl2, but this is ICl2 minus. How can we get the minus? Minus means, you know, 1 more electron is gained. That should be paired with this one. So this is ICl2 minus. But in that particular case, you get 1, 2, 3, 4, 5 repulsive units. 5 repulsive units means what is geometry? Trigonal bipyramid. 2 linear, 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramid, 6 octahedral. That's how we got it. So 5 mean trigonal bipyramid. So yeah, that statement is also true. Then A and D are correct. A and D correct mean it's a fourth answer. So your 16th question, the answer is fourth one. In the previous question, I got question number as 16. It's by mistake. It should be question number 21. This is then 22. Question number 22. Which of the following statement are correct? First one, chlorine has the highest electron affinity. You know, in new syllabus, we take this as electron gain in enthalpy. So electron affinity has relationship with electron gain in enthalpy like this. Electron affinity is actually minus electron gaining. That means if you get highest electron gain in enthalpy, that is where we get highest electron affinity. Like electron gain in enthalpy, if it is minus 200, electron affinity is plus 200. If electron gain in enthalpy minus 400, then electron affinity is plus 400. That's how we get it. Okay, then if you get more electron gain in enthalpy, that is where we get highest electron affinity. So then in periodic variation, you learn going along period, electron gain in enthalpy increases up to group number 17. Going down the group, electron gain in enthalpy decreases. That is the point. According to that, we expect then highest electron affinity in group 17, because in group 18 we get positive value for electron gain in enthalpy, then electron affinity will be negative value for that. Then it should be group 17. Then out of 17 going down, it decreases. Therefore, we expect what? Fluorine. What we expect here, fluorine as the highest one. But you know, there is exception. Out of fluorine, chlorine has highest electron gain in enthalpy. According to that, chlorine has highest electron affinity. You know why? Because you learn that one in theory classes. Since fluorine atom is small, there is a large negative electron density. In that case, when you add electron affinity mean energy change during this reaction. You add electron to this. Okay. Since this has large electron cloud, when you add electron to that one, there will be strong repulsion. Strong repulsion. To overcome strong repulsion, you have to supply more energy. Since you have to get more positive value here, then negative value should be here small. So that's why chlorine has high electron affinity or electron gain in enthalpy. Normally for several other groups, third period element has higher electron gain in enthalpy compared to second period because of this reason. So according to that, then chlorine has highest electron gain in enthalpy, then electron affinity. Yes, A statement true here. Compound with highest ionic properties formed by the reaction of element at the top of 17 and bottom of group 1. So what is favorable factor for ionic compound? There should be large electronegativity difference. That means highly electropositive element and highly electronegative element. You know, electronegativity again, to have ionic one, there should be large electronegativity difference. To have a large electronegativity difference, there should be highly electropositive one and high electronegative one. You know, electronegativity increases going along a period, decreases down a group. That means which one is highly electropositive one? It should be leftmost one and the bottom one. That means group 1 and bottom. That's highly electropositive element. Which one is highly electronegative one? It should be the rightmost one and the first element, top element, because going down it decreases. Okay, then rightmost one, what we get, group 18, but we don't consider here group 18 because group 18 elements normally, like helium, neon, they don't make chemical bond. Then we can't define electronegativity for them. Okay, because of that we take 17 and it is top element, it's fluorine. That's the most electronegative atom. So between these two there will be large electronegativity difference, then there will be most ionic compound. Therefore B also correct. Top of 17, bottom of group 1. That's true then. Atomic radius may decrease across the period from left to right. Yes, atomic radius decreases because effective nuclear charge increase. Nuclear attraction increases, but shielding effect remains constant. Because of that, effective nuclear charge increases. As a result of that, the size of electron cloud decreases. Atomic radius decreases from top to bottom. No, from top to bottom new energy levels are added. Because of that, atomic radius increases. So A correct, B correct, C correct. 3 answers. Then your response should be here 5. 5 is correct. 23rd question. I saw most of you have done mistake in this question. This is from unit 5 energetics. Question is to find out the endothermic reaction. You know, some reactions can be, some type of enthalpies can be decided, predicted as plus or minus. As example, neutralization, acid base neutralization, it's minus, exothermic one. Ionization energy, it's plus, endothermic one. So likewise we can predict it. But what about the first one? Sodium plus electron, sodium gas. A given like this, sodium plus electron, sodium. If you are not comfortable with this one, just think the reverse one. What is reverse? Then I think this is familiar to you. Sodium gas goes to sodium plus. It is the equation for the first ionization energy. During ionization, you know, we break attraction between the nucleus and electron. Then you have to supply energy to break that attraction. This means this process is plus. But now what you are given here, the reverse of this. If this is plus, reverse is minus, you know that. Therefore, first equation process is exothermic, not endothermic. It's not the answer. B given carbon dioxide gas dissolved in water. Right? So, dissolving gases in water is exothermic process. Right? So, when you dissolve most of gases in water, that process is exothermic. Heat is given out. Therefore, B is an exothermic process. C, again not familiar. When you consider C, it's O2 minus gas plus gas goes to O minus gas plus electron. If you are not comfortable with this one, just think about the reverse process. O minus gas plus electron, it goes to O2 minus gas. So what is this? This is second electron gain in enthalpy of oxygen. In this particular case, you know, this is 2s2 2p5. Once it gains electron, it becomes 2s2 2p6. That means it becomes stable. Someone becomes stable, then energy should be given out, so it's minus. But there is another important thing here. This species is negatively charged. That means electron density on this O minus is very high. Now we try to add again electron to this same species, but there will be then strong repulsion, very strong repulsion will be there. Because of that, we have to supply more energy. So energy required is more than the energy released. Then what will be the overall here? Overall will be a positive value. So remember, this process is a positive process. So this is given the reverse of this. Then what about that? It should be again negative process. Understand? That's negative. Next, you are given ammonium chloride solid dissolved in water. Again, dissolving ammonium salts are generally endothermic process. Dissolving ammonium salts in water, that's generally endothermic process. Therefore, that is endothermic. D is the only answer for this. D only mean again 5. Your response should be 5. 24th question again from bonding concept. Which of the following statement are false? Not true, but false. Again, you have to be careful when you answer this type of question. The question is false, right? So, but we are then sometime find out correct answers and then give the final response. But then you don't get the marks. All PCl bonds in PCl6 minus ion has same energy. Let's try to understand how PCl6 ion is formed. PCl5 is the stable one. We don't have a problem with that. All 5 electrons involved in the bonding. But now phosphorus, that's in the third period. Its third period mean it can have maximum 18 electron in the valence shell. That means the phosphorus can accept more electron, because here we have 5 into 2, it's 10 only. So that is why it accepts a lone pair from Cl minus. That is where a dative covalent bond is formed. But you know how dative covalent bond is represented. It's something like this. Since Cl minus donate lone pair, it's plus. All D minus, then cancelled out. Phosphorus gains electron, it becomes minus. So that's how we get the bonding arrangement of PCl6 minus. It's 1, 2, 3, 4, 5, 6 bonds, no lone pair. Then the geometry is octahedral. When you consider octahedral, all the repulsive forces are equal. If the repulsive forces are equal, the bond lengths are equal, then bond energies are equal. So therefore, it's true statement. Dipole-dipole interaction is the intermolecular attraction of CO2? No, because CO2 is a linear molecule and all the forces cancelled out. That has symmetric electron cloud. Between symmetric electron cloud, what we have? London dispersion force, not dipole-dipole. To have dipole-dipole, there should be asymmetric electron cloud. There should be plus minus charge separation. There is no covalent bonds in any ionic compound. Is that true? No, it can't be. Why? When you consider ionic compound like, let's say, sodium nitrate or something like this. First, we have a bond between sodium plus NO3 minus. That is ionic. It's okay. But when you go to nitrate ion, what are the bonds you have? This is how we have the arrangement in nitrate ion. There is double bond, covalent bond. Nitrogen and oxygen share electrons. Single bond, it's covalent bond. What about this? There is a dative covalent bond also. So some ionic compounds are there having all this type actually. So therefore that statement is not true statement. That's false. Boiling and melting point values of any covalent compound are relatively less than ionic compounds. Any covalent is less than ionic. Is that true? It's not true. As example, once you consider SiO2 silica, here it's a covalent compound, but it has giant lattice structure. Because of that, here the melting point is quite high, over 1000. But once you go to the same group like PbO2 like that, these type of compounds can be ionic. Although it is ionic, the melting point of this one is small value, lower than this one, it's lower than 1000. Although it is covalent, it has very high melting and boiling point. Therefore, that statement is not true, it's false. Then in 24th question, only A is correct. Your response should be now 5. We have come to last MCQ, but you know it is a very simple question. Which one of the following hybridization is similar to the hybridization of central atom of NH3? You know how hybridization is predicted? It's according to VSCPR. 2 VSCPR, your hybridization should be SP. 3 VSCPR, it will be Sp2. 4 VSCPR, it will be Sp3. That's how we predict it. 5 DSP3, 6 D2sp3, like that. VSCPR mean both the bonding pairs and sigma bonding pairs and lone pairs. In the case of NH3, what we get, it's something like this. NH3. We have total 4 VSCPR. Because of that, it should be Sp3. Now the first answer, BF3. BF3, only 3 bonding pairs, there is no lone pair. PH3, 3 bonding pair, 1 lone pair, similar to NH3. H2O, 2 bonding pair, 2 lone pair. But how many VSCPR? Total 4. Therefore, it's similar to NH3. 4 VSCPR. Last one, AlCl3. 3 repulsive units only, different from this. So your answer should be B and C. According to BC, your response should be 2. So for last one, 25, answer is 2. Right, that's end of then discussion for the MCQ paper, 25 MCQs. But within 25 MCQs, we discuss so many important points throughout the syllabus. Then once we continue this type of paper discussion like this, that means we are revising the syllabus several times. Is it good? Yes, it's very good for you to keep all the stuff in your mind. And the other thing is, I explain here not the detailed method, long method, but always I try to get the shortest one, simplest one. So then that is how you have to answer your questions in your paper, your exam paper also, because time is very important concept in answering your exam paper. Okay, that's about then MCQ paper. Let's go to structured essay and essay.